Get a few seconds.
Welcome, everyone. My name is Rachel Franco, and welcome to the 2021 ITS Canada Student Essay Presentations. First, Rish Malhotra, CEO of International Road Dynamics and sponsor of the 2021 ITS Canada Student Essay Contest, will say a few words, followed by Bilal Farouk, Chair of the ITS Canada 2021 Student Essay Contest. Take it away, Rish.
Thank you, Rachel. Hope you can hear me well.
Yes.
Okay, good. Thank you. So yeah, thanks, Rachel. You know, IRD is really proud to be a student essay presentation sponsor. And, you know, I just want to spend a couple of minutes talking about our purpose and what we do. You know, for those who may not know IRD very well, we are a global leader and in delivering technologies that improve road safety and enhance environmental sustainability. So we basically use our technology to create a safer and greener world. And that is really front and center in everything that we do every day. So we are proudly celebrating our 40th year this year, and we operate in all the continents across the world. We have several offices, many in North America, Latin America, Europe, and we are in about 80 countries worldwide. The countries in blue on this map are the ones that have been using our technology to really enhance the safety and efficiency for many, many years. Just a quick snapshot on the different verticals that we operate in. I mentioned earlier commercial vehicle enforcement. That's really truck compliance and safety, which is our core business. And this also includes other adjacencies like bridges, ports, borders, mines, which also extends not just into commercial vehicle enforcement, but also into access control and security. Additionally, you know, we're also a pretty strong player in toll collection systems. We've got almost 7,000 lanes of toll deployed worldwide. And we also have several highway traffic management systems around the world. And last but not the least, we have our own service and maintenance teams that are adding value to customers and servicing the technology that we deploy, in addition to a lot of data services and analytics. Just before I end, a quick other couple of notes. IRD is part of the Quarterhill group of family. And at the Quarterhill level, we publicly announced last year, same time, that we have a goal of deploying about $400 million to grow inorganically in the next 5 years. So we started this year pretty early with 2 acquisitions in Germany that are now enabling us to evolve into IRD Europe. And in fact, I'll be announcing our new managing director of IRD Europe next week. Also, last quarter, we had ETC from the US. They're a leader in tolling. They joined us as our tolling platform. And as you can see from the map over here, we are a dominant force in commercial vehicle enforcement, in tolling, and now we are quickly expanding also into some of the other verticals that you see on the slide. So that's it. With this, I hand it back over to our fabulous conference host, Rachel. Thank you.
Thank you so much, Rish. That's perfect. I'll just pass it right on over to Bilal Farouk, Chair of the ITS Canada 2021 Student Essay Contest. Bilal?
Thank you very much, Rachel. So first of all, this year, we were very excited to see the kind of vision that students came up with and their ideas and how they can be the future leaders. This year's topic was creating connections that matter, and we had some excellent essays being written. What we are really proud of this year is that we included 2 very distinct changes. One of them was that we specifically asked the students to write their thoughts about diversity, equity, and inclusion leadership, and we got some fantastic content related to that from students. And at the same time, we also opened it up for international students. So again, we had a very, very good response regarding that. So with that, I'll invite Lena Al-Murshidi, who is a PhD student with Professor Bahar Abdulhai at University of Toronto, who won the first prize to present her presentation. She'll have about 5 minutes to present, and if you have any questions, you can write the questions in Q&A pan, and the floor is for you, Lena. Please go ahead.
You're muted, Lena. Oh, you're still muted.
Oh, okay. Do you hear me well now?
Now we can hear you.
Okay. Thanks, Professor Bilal, and I'm grateful to be selected as a winner for the student essay competition, and I very much appreciate the support offered by ITS Canada. So my essay topic was about evaluating the impact of adaptive cruise control systems on congested freeways and how this emphasizes the need for implementing new traffic control strategies. So to start, as you may all know, as you may all know, adaptive cruise control systems is one of the most mature automated vehicle technologies in the market nowadays, where the driver chooses two things, basically the desired speed and the desired time gap, and then the system operates either in a speed control mode when there is no preceding vehicle trying to maintain that desired speed, or in a space control mode where there is a preceding vehicle and the system tries to maintain the desired gap in here. So the challenges with the advent of such systems is that most auto manufacturers recommend long headways or long time gaps for safety concerns. And if users abide by such recommendations, this will lead to a capacity decrease in our road network. Also, the capacity will decrease if such systems will impose smooth accelerations or decelerations for convenience. And one more thing, the small time gaps will or may lead to merging problems. So the need is to first model these systems in order to quantify their effect on the transportation network, and second, to introduce suitable control strategies to reduce any deteriorations they may cause. So talking now a bit about the literature studies quantifying the impact of ACC systems. So some of them either adopted a best case scenario where minimum headways were assumed, negligible reaction times were used, small networks with no bottlenecks also were used for quantifying the effects of such systems. And this led to kind of a best case quantification scenario. Other studies adopted a worst case scenario where they adopted long headways, conservative acceleration settings, and this also led to a worst case quantification. So we aim to address those gaps by first quantifying the effects of those systems or ACC systems on a long and congested freeway with multiple bottlenecks and hotspots. We also tried to adopt different headway settings where we had a long headway setting, short headway, and range between both with a normal distribution. And we also assumed to have two different reaction times. One of them is a human-like reaction time and another optimistic low reaction time. And we chose this optimistic low reaction time to be a bit doable, not like the negligible reaction time we saw in the literature. So to quantify, in order to quantify the effect of both. Just give me one moment, please. Sorry about this interruption. And the last thing we wanted to do is we wanted to adopt different car following models for ACC representation, mainly to observe general performance trends resulting from both models and to highlight the shortcomings of any based on the traffic simulations. So these are the sample results of our ACC quantification work. Here we're seeing the delay results for 3 different headway settings. We used a 2-second headway represented by the yellow bars over here, representing the worst case scenario. We chose 0.8 second short headway, represented by the blue bars here, representing the best case scenario. And the orange bars here were headway between those two ranges, 0.8 and 2. And over here on the left, this is the when you assume the 1.1 second reaction time, which is the human life reaction time, and then we also used a bit lower reaction time, which is the 0.8 second. We on the x-axis, just to make it a bit clear, we have the penetration rate 25, 50, 75, and 100, and on the y-axis we have the percentage of improvement or deterioration from the 0% of ACC. And the two things we wanted to highlight here is the headway effect and the reaction time effect. So as we may all see that the headway effect, when the headway decreases, the delay decreases, and when it increases with the yellow bars, the delay increases. And also, even with the range headway, we found out that some improvements are even possible, even if they are not that significant. And if we look into the reaction time effect, the deteriorations were not very much affected, whether we used a long or a small reaction time, a large or a small reaction time, but the improvements further increased when we adopted a small reaction time scenario. So this brings us to the traffic control with ACC. In order to reduce the deteriorations caused by using conservative ACC headways, we wanted to introduce a controlled ACC strategy which adjusts the ACC time gap in real time based on the prevailing traffic conditions, where this strategy receives real-time measurements or estimates of the traffic state every control cycle. This can be via loop detectors or via vehicle to infrastructure communication, as an example. And this is, again, the last thing, the sample results of our control, where we have the delay difference with respect to 0% ACC. We here have two scenarios when all ACC users on the left adopt the long headway, and on the right, we have when all ACC users choose between a 0.8 and 2 with a certain distribution. And as you may all see that here, all the delay increase that we've seen with the long headway setting turned to improvements. With the range headway, we've witnessed some improvements, and those improvements increased further with the ACC control. One thing to note here is that the short headways were only imposed in our control strategy in critical and near critical traffic situations, first in order to avoid breakdowns, and second for safety concerns. But also we aim to address this limitation by considering safety in addition to efficiency when imposing headways on freeways. And this brings me to the end of my presentation.
Thank you, Lena. Do we have access to questions? I don't. Rachel, do you have access to the question?
We will, but I think we'll have the Q&A after Magut's video.
Okay, thank you. So with this, we are going to move to our first runner-up, who is Magut Gouda. Unfortunately, he could not make it, but he has sent us a video. He is from University of Alberta, and his PhD advisor, Professor Karim, is here. So could you please play the video?
Good afternoon, everyone. I am Magut Gouda, and I'm a PhD candidate at the University of Alberta. And before I start, I would like to take the chance to thank Yannicki and the ITS committee for selecting me for the 2021 Essay Award. I'm very happy of this achievement, and I'm very grateful for the recognition. And the focus of my essay in general was on emerging trends in infrastructure, digitization, and HD mapping. Before I start, just a very brief background about the topic. There recently has been an ongoing race for transportation automation, and this, of course, includes the mass deployment of connected autonomous vehicles, or CAVs. These technologies are expected to cause a massive paradigm shift in many aspects, such as road safety by reducing collisions, and mobility by efficient data flows of CAV systems, and many other expected benefits. Several countries already adopted national visions for the deployment of CAVs. This includes, for example, UK, countries in the European Union, Australia, China, and the US, of course, the arrowheads of this race. And Canada is also working on plans for deployment of these technologies. The testing of these technologies, however, is not always successful due to CAV limitations, which delays that deployment plan. The essay then discusses examples of these limitations, such as adversarial examples, sensing limitations, occlusion, and also the constraints of the computational system on the local vehicle system. And then the essay goes into two main trending approaches to resolve such limitations. And the first one is supporting CAV's high definition maps with semantic layers of road information and datasets. And the second of these is the enhancement of road infrastructure readiness for CAVs. The essence of the two is, of course, to improve AVs perception, or autonomous vehicles perception, and connectivity to the physical infrastructure. The essay also briefly goes into the methods applied in my research, and that figure on the left is an HD map created from my PhD work, which is more detailed in the explanation inside the essay. This is a list of references I used in the presentation. And thank you very much. Thank you again, Yannicke and the ITS team. And please feel free to reach out to me if you need more information about my essay, methods, or publications. Thank you very much, and you guys enjoy the rest of the conference.
Thank you. So with this, we are going to ask a couple of questions. Only Lena is here, so if you could please reply to those questions, that would be great. One of the questions that came was that from the audience, how did both Lena and Magut, in your case, for instance, you approached this essay challenge compared to a research paper? So you've been trained to write research papers, but at the same time, this essay had a very different goal. So how did you adapt to it, and how did you approach it?
Yeah, for me, it was a bit tricky since I haven't written essays for so long, but yeah, I did some academic writing, but so I revised my work and I tried to formulate it as a story. I tried to first see how can the story be told, and then what's being told in the literature, and how will I say it differently, and what are the conclusions overall from both the literature and my approach. So yeah, kind of that was my approach to do or to write the essay.
Thank you, Lena. I have a question for you in the sense that if you were going to give a piece of advice to, say, OEMs, the car manufacturers, or municipalities, so what are the key points that you would like to convey to them, individually or collectively?
Well, it would be not only for the car manufacturers, because I understand that manufacturers in the end aim to deliver end products that are safe, but it is the integration between the manufacturers and the planners, transportation planners, or maybe the government planners, is the thing that may be needed in order to have or take advantage of those new technologies without jeopardizing safety, for example, or without affecting road capacities negatively, as we've seen.
Great answer. Thank you so much. One more question, if I may ask.
Sure.
So in terms of the penetration rate of these ACC technologies, mm-hmm. Where do you think that there is a good amount of benefit that you can produce by utilizing your research? What is the kind of threshold that these ACC should have in the flow?
Well, it is understandable, of course, that as the penetration rate increases, the improvements will be more. But even with the least penetration rate that we've considered at 25, some improvements were possible. Another thing that is to be mentioned is that the maybe ACC vehicles or autonomous vehicles in general will be more strictly complying to the speed limits, and that's what we found. So at 100% penetration, for example, in free flow conditions, the human drivers seem to achieve much better. So it's kind of like a trade-off, like whether we are in congested conditions, whether we are not, and yeah, how will this end up?
Thank you, Lena. So we'll give one final chance to the audience if they have any questions. Kareem, do you have a question? Or, okay. Yeah, so I've been asked to ask Kareem if he could actually give some insight into what was Magid's process in terms of writing this essay.
Oh, thank you. Well, I can't really speak on behalf of Magut, but we did talk briefly about this when it came across. And I said, Magut, it's really important to keep in mind your audience. And as Lena has so described in her response, I think your approach to this shouldn't be that you're writing for, your peers in the scientific community. You need to make the language much more approachable. You need to phrase it such that you're talking about a story. And so with a story, it has the three sort of parts: the beginning, the middle, and the end. And so the more interesting stories are the ones that are personal and they relate to the stuff that we kind of face on a day-to-day basis. So I think Magut did a good job, apparently, otherwise he wouldn't have been selected. And on behalf of Magut and the U of A team in general, we'd like to thank ITS for this great honor.
Great, thank you. And my apologies, I did not pronounce his name right, Magut. And one final comment that I've been told to state is that Lena, she'll be receiving $2,000 as a first prize, and Magut, he'll be receiving $1,000 as his second prize. So with that, I'll move it to Rachel. If you could please wrap it up.
Perfect. Thank you so much, Bilal. And let's give a round of applause for Lena and Magut. Congratulations to you both. And thank you, of course, Bilal, for being the chair of the ITS Canada 2021 Student Essay Contest. Those are absolutely fabulous, interesting topics. Please don't forget to join the discussion roundtables sponsored by SEMA Plus, which are just about to start. And finally, if you're a social media user, post your conference insights or experiences as they happen during the conference with the hashtag ITSC 2021 on Twitter, LinkedIn, or Instagram. Thanks again for joining us and take care. Bye.
Thank you.